Hello everyone, my name is Farid Zirat. I am a PhD Senior Application Engineer within Altair. Welcome to this session on Ask the Expert for eccentricity computation. As you can see, the eccentricity, there are a lot of kind of eccentricity, static, dynamic, mixed, and what you can see on the screen is for radial flux machine, and there are other more complex eccentricity, axially for instance, so then we need to move to the 3D. The topic of today is of course eccentricity, but I am not going to talk on the eccentricity on radial flux machine, but mainly on axial flux machine. Right? Why I am going to talk about eccentricity on axial flux machine, because with the new features of 6 degree of freedom, the eccentricity now is made easy. My colleague Nicola has already made an article on Altair community that you can access. So he built a macro in order to make these different eccentricities, and actually it's well explained here how to use this macro in order to define static or dynamic or mixed eccentricity. In the same article you can find the macro because it's not yet integrated in current version of Flux 22.1.1. So you can access to it from this article. And actually you have also a detailed PPT where you can find all the information on how to use this macro for your radial flux machine. Okay, so then if I go to the Flux supervisor, I have already prepared a few examples on a really simplified axial flux machine, which is for me two disks, one fixed disk and the other one rotating. So then you can start from your healthy project. That means that there is no eccentricity. So you have already defined all the volume regions, the fixed part, and the mechanical sets, the circuit. So in your healthy project, since there is no eccentricity, then we are going to use a sliding cylinder. So it's a volume of air surrounding all the mobile part. For me, the mobile part is the one on the bottom. So there is a disc of iron and two magnets, the same thing on the top, which is fixed, a disc of iron and two magnets. So the mobile part is rotating around the axis. And as you can see, I have already defined two mechanical sets, only mobile part and a fixed part. Okay. For the different eccentricities I am going to define today and show you today, I need to make some modification on this project. So the first one is to create a coordinate system. So I am going just to select one point in order to see the location, minus 10 millimeters. I will call it mobile, and it will be located at minus 10 millimeter. Okay, so this is the coordinate system I am going to consider when I will create my new mechanical set using 6 degrees of freedom. The second thing I need to modify in this project is that I am going to delete the mechanical sets as well as the scenario using driving the position of the rotor. So first I am going to select all the regions, edit array, and unselect, so there is no mechanical set. And I am going to delete this scenario, because if I edit it, you can see it's using driving the position of the rotor. With 6 degrees of freedom, I cannot drive the position, but I can only drive the time. So let's delete it. Okay, I am going to delete the mechanical cells. Okay, so I am going to create now 3 new mechanical cells. The first one is a fixed one. Okay. The second one is mobile. So here I am going to use the new feature using 6 degrees of freedom. And I am going to select the coordinate system I created previously. It's located on the mobile part, and it's a multiphysics, mechanical set. Okay. And since I will have an eccentricity, so then I can have a mobile like this, or something moving around another axis, then I need a remeshing mechanical set, which is a compressible one. Okay. Then it's okay for me. I have to assign then the new regions. So the air rotor surrounding the mobile part will be using my new mechanical set remeshing. The air stator is a fixed one. The magnet on the rotor will be mobile. The magnet on the stator will be fixed. The rotor, of course, will be mobile. And then the stator here will be fixed. Alright, so then I have defined my project, and it's ready now to make eccentricities. Something you have to notice is that when you create this 6 degrees of freedom, Flux will create automatically these parameters, right? So we have to define a rotor mobile around X, around Y, around Z, and the translation. That means we can define now rotation and translation with impulse speed, for instance, or with a multi-position or something like this. And this is what I am going to use in the second example I am going to show now. It's mainly static eccentricity, dynamic eccentricity, there are axial, and so on. Okay, so then if I want to define this eccentricity, like axial static eccentricity, so I have smaller gap here and a bigger gap here, which is mainly like this actually. So the rotor is moving around the z-axis of mobile coordinate system, and it can be, this is mainly the static eccentricity I am going to define. Okay, so how to define this through the new 6 degrees of freedom mechanical set. So let me go to the physics and go to the parameter quantity I created. So there is no speed around x and y axis, but there is only rotation on z axis. So here I multiplied by 6 in order to move from round per minute to degree, because this is what we need here. And so typically the speed here is 3000 RPM versus time. So this is what I have as a speed around the z-axis. So there is no translation according to x-axis, y-axis, and z-axis. Okay, then I have to define a scenario, edit, and this time the scenario is mandatory to define it versus time evolution, right? And here I defined like a period of 20 milliseconds. And once it's done, you can solve the project, and then you have possibility to plot this. Something you need to do here when you want to compute the torque using this new feature, for instance, mechanical set. So there is no possibility to select the mechanical set. Here, the thing you need to do is to create a sensor, and the sensor is a predefined one. So you have to select the torque. Let me magnetic torque. Select the axis of the rotation. We use the mobile coordinate system. We will center it on it, and we are going to select only the magnetic region rotor. Okay. And then you have to evaluate then the sensor. Once the sensor is evaluated, then you can go to the sensor again, right click, display curve, and then you have the torque. Of course, this example has no physical meaning, so I have really no physical quantity here. Okay, then what about the dynamic eccentricity? So the dynamic eccentricity, that means that the dynamic axial eccentricity, it means that the rotor is moving around the z-axis, but I have like a dynamic air gap, so it will be small and large, small and large according to the time variation. How to do that? Again, there is now rotation on x-axis, but I am going to make now a movement, so a rotation, but no rotation, a movement on an angle of 2 degrees around y-axis, and it will be a function of time. And as you can see here, I will use 50 Hertz. So the movement will have 50 Hertz around y-axis between -2 degree and 2 degree. And then of course I will keep the rotation as it is around the z-axis, about 3000 RPM. There is no translation on x, y, or z-axis, right? Okay. Then the scenario is always defined function of the time. I can edit it again. And I am going to solve the project. Well, when the project is solved, I can, of course, make an animation, for instance, in order to see. Maybe I can put it like this. And then I can start the animation. Yeah, then the animation, I can, once it's built, I can launch it, so we can see really how the axial dynamic eccentricity it is. Of course, again, I can create a sensor in order to compute the torque on the mobile part. And it's again parallel to OZ. And on the mobile coordinate system I created, and I have to select only the rotating part. Okay. And the sensor, once it's created, I have to evaluate it. Once the sensor is evaluated, I can then display the curve on it. And okay, this is just a demo, but yeah, the torque here has no physical meaning. Well, now if I want to make like axial dynamic eccentricity like previously, and plus radial dynamic eccentricity like this. Okay. I will try to see on the other side. Okay, so let me create another one. So for instance, you can see that this is a view on the axial dynamic eccentricity, but you can see it also here that there is also a radial dynamic eccentricity. So how to define that? Let me open a non-solved project. So again, thanks to the 6 degree of freedom defined in the mechanical set. So again, no rotation on X axis. I am going to define this rotation on y-axis to define this dynamic eccentricity, axial dynamic eccentricity, like this, between minus 2 degree to 2 degree with the frequency of 50 Hertz. A rotation around z-axis of 3000 RPM. Then to define this radial eccentricity, I need to impose a translation on x-axis and a translation on y-axis. So the one is defined in sinus and the other one in cosinus. So then with the same frequency, it means 3000, it means 50 Hertz, yeah, then it means 3000 RPM. 0.02 is the eccentricity radially. So I have like 20 millimeters like this. Then there is no Z translation, okay? And the scenario is always defined as driven by time. Then I have to solve the project. And once it's solved, you have this possibility to see and make animation like this one or the other one. And of course, again, create a sensor in order to compute the torque on the mobile part. The other funny thing I want to show you today, it's not an eccentricity, but thanks to this 6 degree freedom, we can now make like a rotation and a translation. And here we can, for instance, make like a rotor, a screw motor. So it's rotating and translating in the same time, right? So this was not possible in the previous version of Flux, but now thanks to this version and feature we can do it. And to do that, you have to define a translation around z axis and make a rotation around z axis of, for instance, 3000 RPM. Alright, this is all what I have to show you today. I hope that you enjoy this new feature and how it is now easy to make this different eccentricities. So please feel free to ask your question now, or maybe send us a question later if you need. Thanks a lot. Bye.